do you understand when by the term harmonic force? Have you studied harmonic analysis of harmonic force? The effect of harmonic force on a system?
The harmonic force is the force which occurs at this at a same amplitude at regular intervals.
So can you see my what do you say my pointer? This
Yes, sir.
sawtooth shaped signal. Can you see that? Okay. So this is also same. No, amplitude is same, and it is occurring. It is repeating after a fixed period of time. So this is also. So is this signal harmonic?
No, sir, I think it's periodic.
It is periodic. It is periodic, but it is not harmonic. So when you say harmonic, it has to have a sine or a cosine component attached to a fixed amplitude. So if you see this signal, the amplitude of the signal varies and it is given by the equation a sine omega t. Okay. So for example, when you are doing solving problem, you have this force attached to a mass, and it is given as F is equal to F sine omega t or F is equal to F0 cos omega t, something like that. So that type of force is called as harmonic signal. The other examples of the signals which are given, these are called as periodic signals. Now, what does the fast Fourier transformation do? For example, if you take this periodic signal, it breaks down into an infinite sum of sine and cosine terms. Okay? Infinite sum of sine and cosine terms. Now, this signal has been created artificially, and it is created by superimposing these three individual signals. Okay? And these three individual signals are these three are individual harmonic signals, and these harmonic signals are the output of these harmonic signals is added together, and you get this resultant signal. Okay, so now what does the FFT analyzer do? It breaks down this signal and identifies the frequency, and it breaks down this signal, and what it will do, it will identify the frequency and amplitude of the of the various signal which makes this which and decomposes this signal. Okay, so when I apply a fast Fourier transformation on this signal which is on this left, what the output which will I get will be the frequency and the amplitude of these three signals. So on x-axis I will get the frequency, and at a particular frequency what is the maximum amplitude. So that is what the FFT analyzer does. Okay. So this principle it is not necessarily applicable to a sinusoidal form of signal. It can be applied to any form of periodic signal. Okay, for example, this is a sawtooth. Now I can express this sawtooth into sum of infinite number of sine and cosine waves like this. Okay, so I can go on adding this what you say sinusoidal and cosine terms, and if I combine the signal of all these infinite signals, I will get this original sawtooth. Okay, so the equation for fast Fourier transformation is xt, that is the signal. So I am breaking it down into uh, uh, infinite number of sine and cosine terms. So on the right hand side I get a0 by 2, that is a constant term, plus a1 sine omega t plus a2 cos 2 omega t, and so on and so forth in multiply omega, plus v1 sine omega t plus v2 sine 2 omega t, and so on and so forth. So if we come back to our sawtooth signal, so this is the original sawtooth signal. Now I want to apply Fourier transformation to it. So if I just include just one term, this constant term, I will get this horizontal line. Okay. Now the more the terms I start to increase, then this signal will become more and more closer to this original sawtooth signal. So the more the terms I have on the right hand side of the equation, more it will appear closer to the original signal, that is the sawtooth signal. And this equation in general can be written as a0 by 2 plus summation of a n cos n omega t plus bn sin n omega t, where n is equal to 1 to infinity. Any questions so far? Can I continue? Okay. All right. So, and how to calculate these terms? These are given by these integrals, and this you should have already learned this in the earlier course. So, I'm not going to derive these equations for you again. You just have to just make a note of it. That how these terms appear. Okay, so this is how we will get these terms when you do the integral. Now,
So, uh,
yes,
sir, in the previous slide, uh,
yes,
no, sir, the formulas one.
this one. Huh.
No, sir,
Yeah, go ahead. Before
the,
this,
yeah, no,
this, huh.
for the eighth one,
This one.
eighth slide, sir.
This is the first, second, third, fourth, fifth, eighth. Eighth slide, huh?
Ninth slide, sir. Sorry.
Ninth, huh?
Yes, sir. Omega by pi, integral of xt dt, I understood, but is equal to what is the symbol below 2?
Time,
Okay, time.
time. This time.
Okay, tau. Okay.
So now suppose let's come back to our original harmonic signal. Now when I apply the fast Fourier transformation to this signal, now fast, what do you understand by applying fast Fourier transformation? See in Matlab there is an inbuilt function called as fast Fourier transformation. So what you can do, you can the exercise which we are going to do today in Matlab, in this you will be creating a function and then you will be doing a fast Fourier transformation to that signal, and then you will see what output you get. Okay. So, but in practice you don't have to do it in this way. In practice you will take the signal. Suppose there is a machine for which you want to do vibration analysis. You are going to attach some kind of a vibration measuring device to that machine. Take the output onto the computer, and then from that output you are going to apply the fast Fourier transform. So fast Fourier transformation is basically an inbuilt mathematical function, and what it does. I am not going to dwell into how it does it. Like it is doing the theory I have already explained. I am not going to explain the programming logic because that is that is inbuilt in MATLAB. Okay. So now if I apply a fast Fourier transformation to this signal, what I will get is on x-axis there is frequency, on y-axis there is amplitude. So it will give me the frequency at which the amplitude, for that corresponding frequency, what is the maximum amplitude, right? For this particular harmonic signal. So then I will know that at this natural frequency, this is the amplitude. So can be if the system is operating at that frequency, then I can expect the system to vibrate at this particular amplitude. So that is the information that will give that you will get from this fast Fourier transform. Now let's come back to our signal which we have developed. Now if you remember, I have told you that this signal which is shown on the left hand side, it is created by superimposing these three individual signals. These three individual signals which are shown by these three sine waves. One is in blue color, one is in red, and one is in yellow color. Okay. So each of these three waves have a particular frequency and amplitude. Now if I apply the fast Fourier transformation to this signal, can somebody guess what should I expect? What should be the output of that on the screen after I do the fast Fourier transformation? Because this is what you are going to do using a small program that I will be sharing in a few minutes. So, but now can you answer this question? So, if I apply a fast Fourier transformation to this signal, which I am showing by this arrow mouse pointer, so what should I expect?
So you can expect the frequency where the
Yes.
amplitude is the highest, and it seems to be.
So, but how many such frequency will I get? Let's go back to the previous slide. See, this signal is composed of three individual signals. Each individual signal will have a frequency and a corresponding maximum amplitude. Okay. So when I apply fast Fourier transformation to this, I will get three fundamental frequency f1, f2, and f3, and correspondingly I will get three amplitudes a1, a2, and a. Okay, so that is what this fast Fourier transformation does. Now in practice, you will not be doing. This is not how it will be working. You will get some kind of this form of a random signal from and that you will get it from the machine for which you are measuring the vibrations. So, for example, if you go to your workshop and there is a shaper machine, so the shaper machine has some vibration. So you attach some kind of a vibration measuring device to that shaper machine, and then you take the readings and say read it out in the computer, and then you feed it to the FFT analyzer, or feed it to the MATLAB and do the fast Fourier transformation on this. So what I will get? I will get the first, second, and third natural frequency, or I will get the fundamental frequencies of this from which is from this signal. Okay. So now here I have what now when you are analyzing this signal in practice, you have to decide up till what range you want to analyze this. So for example, here in this case, I have restricted my analysis to around 50 hertz. So in the range from 0 to 50 hertz, I get these three fundamental frequency. And how do I identify the fundamental frequency? Because at this particular frequency, the amplitude goes to a peak value. It will shows this sharp peak. So I can identify three natural frequencies for this system when I analyze this system from 0 to 50. Right? How many natural frequency will a system have in general? How many natural frequency does a single degree of freedom system with a single degree of freedom have?
So one.
One. So in general, if you talk about real life system, how many natural frequencies can you expect that system to have?
So in general, it must be 3 degrees of freedom. So three.
Why only three? It is a flexible material, right? There is elasticity. So how many degrees of freedom does a elastic? Suppose there is a elastic beam, continuous beam. So how many natural frequency will a elastic beam have?
So if it is elastic, then it will have many degrees of freedom. So
Infinite
n
degrees. Okay.
in n.
So
Yeah.
the system in general will have infinite degrees of freedom. So we do not need to collect the data on all this frequency. We need to collect the data where the amplitude is going beyond the what do you say, some kind of a design value, so which is not acceptable to the design. And we have to design the systems in such a way that the system doesn't operate in that frequency range, or whenever it operates in that frequency range, it should be only for a very short period of time. It should pass that frequency very quickly. Right? For example, when you start your say, ceiling fan, the ceiling fan doesn't go immediately to the maximum speed. Right? It starts from 0 and it goes to maximum. Somewhere in between, it will pass through somewhere in between, it will have its uh, fundamental frequency, first, second, third, and so on and so forth. So when the signal is transmitted from Okay, sorry, I got disconnected because of the net connection. So now if I expand the range and if I collect it beyond this 50 hertz, I will get more such natural frequencies for this. So up till what range I need to collect, that depends upon the what kind of application you are working on. Right? So this is all about the FFT analyzer. Now what I want you guys to do is write this program. So this is the program. You can write it in Matlab and run it, and you will see the here in this. If I have used the fast Fourier transformation function, and you will see the input and the output. Input is this what you say, this sine wave. Okay, this V, that is voltage. Okay, so this is the input, and I am applying the fast Fourier transformation to this voltage, and you will see what is the input and what is the output. Okay, and how the FFT analyzer works. So I will share this program with you on the chat. All right, so I have uploaded the program on the chat, so you can download it and write that program in your MATLAB editor and run the program, and then you can discuss the output. All right, so you can do this exercise. In the meantime, I will be also doing the same. Any question? So that is the 10th experiment. I have already added the 10th
Sir,
experiment. Yes.
so you said that this can be asked in the theory paper as well, right?
Pardon?
This can be asked in theory paper as well.
Yes. Yes. Yes.
So,
It's
so,
a question.
uh,
Yes, go on.
so, will it come as a theoretical question, or do we have to do the numerical part
Yes,
of it?
short note on FFT analysis. Many times this is a very popular question. Write a short note on FFT analyzer. So You can
Oh,
verbalize
it will be
whatever
a theoretical question, right?
theoretical. Not to write a program, it will not be like that.
No, no, so I thought we had to do numerical, like using Fourier formula.
No, not numerical. Just to explain how the Fourier transformation works. But you have to verbalize whatever I have explained to you.
Yes, sir.
So I will start the correction one by one, and in the meantime, so both A and B division students, those who have some have Matlab, can write this program. For A division students, this submission of this is compulsory. For B division students, I am not sure, it is optional. It will depend upon Sachin sir. If he wants you to submit it, then he will what to say, create that assignment. But this is a good exercise. It will help. So now, when you are writing this exercise, you have to A division students. You have to add this other things also. Aim. I'll just share the format. How this should look like. It should have the aim theory, all those components it should have. So let me just share the screen. So like this, you have to prepare a format. You can use the Word document which I have given you earlier. So this
So
in
can
this
you provide
format.
us with the Word
No, this
document?
thing you have to prepare. I will just give you the outline. How don't like just do a copy paste of everything. You can use your words. Okay, so aim, then theory. You can write some explanation. Then write type the code. Okay, after you type the code, then this is the input and this is the output. So in that manner, in this fashion, you can arrange your write-up. Don't take a screenshot of it. You have to type it and submit.
Yes, sir, but the outline of it, which contains the college name, mechanical vibrations, and all that, we
So
how do we?
that is there now. It's, that one of the right. I think I have that is there in the assignment.
Uh, Actually, sir, FFT analyzer is not assigned to us yet. That's why.
It is only programming. That you can prepare from the earlier write-up also. There are some write-ups in this format is available. Simple compound, I think it is available.
Okay, sir.
Yep, some Word document I think it should be available. Check. One of the, I think it is there in that Matlab exercise only. Study of experiment, I surely remember. I have given you the stamp. Consider Okay, I will share the gyroscope write-up with you guys on the chat, and it has the template. You can use the template to create uh, this experiment.
Okay, sir. So we write the aim, the theory, and then the code and the output, right? Input
Yes.
output graph. Okay.
I'm sharing the gyroscope write-up with you on the. I already shared it. So this write-up has that what to say all those what template and all those things. Okay, you can just open that on the chat and make sure it says mechanical vibration, not dynamics of machine.
Okay,
Can
sir.
you see? This is the write-up. Okay. So here everything you have to change. Yeah? Title of the experiment and all you have to change.
Yes, sir. Got it.
Title keep it same. Aryan Nashar, are you online? Hello.
Yes, sir.
Aryan Nashar.
Oh, sorry. No, I'm not.
Anybody from A1 batch who is online? अक्षत बढ़ जाते.
Yes, sir.
So this is a common instruction. Have you submitted your gyroscope experiment?
Yes, sir.
Yeah, yeah. So in that gyroscope experiment, see, you need all the students just pay attention. You need to change this. What do you say? This subject name here, dynamics of machinery and subject code. I have uploaded the PDF. So you must have the Word document with you, right? So you can just edit
Uh,
it uh, in that Word document. You have the Word document. No? I have just given you the Word document on the chat.
okay, yes, sir. I'll do it.
So you must have the Word document which you have downloaded, no? That you have converted into PDF. No?
Yes, sir.
Yes. So just edit that original Word document and change this from dynamics and machinery and this code. It should be changed and it is there in your assignment section. Uploaded in the assignment section. Then the correct. It should say mechanical vibration and this should be the code. Okay. I
Yes,
uploaded the PDF in your assignment. Right? So just change it and just re-upload. Okay. So that is a
yes,
common instruction to all, not just one student.
Sir, I've run the code. Uh, can I show
Okay.
you if this figure is right or not of the output and the input signal?
Pardon?
Can I show you if this graph is right or not of the output and the
Yes,
input
sure.
signal?
Yes.
So can you make
Let
me
me.
presenter or something?
Yes.
Sir,
And
it's Jan
then
Jan.
which one? One, no?
No, no, sir. It
There are
is
multiple Nishan.
JANI. It is JANI.
JA.
N NI NI.
Jani. Jani.
Yes, sir.
Yes. You can
So is this the
share your screen
output?
now. Wait. It is still. It has not come up. Okay. Can you just enlarge the? Yes, this is correct. This is the output at
This
10.
is the output
See,
and
if
this
you
is the
see the
input,
code,
right?
correct.
Okay.
Yes.
Okay, so got it. Thank you.
See that you can also verify from the code also. Okay. You see the code, you should read the code. Let me share now. Let me uh, share my screen. Can you see the screen? So in this, see, frequency is given as I set it as 10 and amplitude is set as 5. Okay, so you see the output on the x-axis, you will see the frequency, and in the input, you will see frequency and amplitude. Wherever that peak appears, it will show on x-axis. It will show that 10 as the frequency and 5 as the amplitude. If you change these values, it will also reflect in your output.
Yes, sir. Correct. Understood.
Got it now?
Yes, sir. Got it. Thank you.
So I will come back in a minute. I just have to go to the exam section. You can keep start preparing the report. Keep it ready.
Hello, sir.
Hello? Hello, do you have any questions?
Yes, sir. In the theory part of the FFT analyzer,
Huh?
we can search on the net and find out the theory, right?
You can search on the net, or you can just, what do you say? Yeah, you can search on the net. Fine.
Okay, sir. Got
Any
it.
other
Thank.
question? Hello? Anybody else has any other question? Okay, I will be back in few minutes. Huh?
Hello, sir.
Hello, Devashish.
Yes, sir. For the ninth experiment, for the gyroscopic experiment, so actually I have taken a print and I have uploaded. So,
Yeah,
sir, the
you can
changes that you, yes, sir.
label on that.
Yeah, if I can just cut that and if I can add there and I can re-upload.
Yeah, yeah. That,
Will that do?
yes.
Okay, okay, sir. Thank you.
Any other questions? Hello. Yes, anybody has uploaded the program, the complete program along with the write-up?
Sir, I finished the write-up, but there is no assignment or something created in our division yet.
So right now you can treat it, you can keep it ready. I will just talk to Sachin. He will, if it is required for your division, he will create the assignment. This is an extra assignment, extra what you say, experiment that we have done. So he may or may not include it. If it is not included, at least you got something out of it. So it's a very useful what you say package module in Matlab that you can use in your project also. You can do some kind of project work where you can do analysis of vibration of some machine, and you can take that output and give it as use it as input to Matlab, and you can do the analysis. So something like that also you can do. Just keep it ready if it is required for your division. So V division just do the coding part. Other part, if it is required for submission only, then do it. Is that clear?
Okay, sir, got it.
So coding will be beneficial for you anyways. So, at least you can do the coding part. Other stuff, it is if it is required by if it is asked by the teacher, then only then do it. All right, we will stop for today. A division have you submitted the? I think 3 students have turned it. I can see. Just check. Harsh Mistry. Harsh Mistry is online. Hello. Bhavya Shah. Atul Kumar Sharma. Okay. How many students have actually written, wrote the program and got the output?
Sir, can I show you my Word document by screen sharing if it's proper
Sure.
or not?
Yeah, go ahead.
Sir, can you see?
Yes. Can you expand that screen? Full width, you can increase it. Yeah, that's better. Yeah, now scroll down. Scroll a little bit more. Okay. Theory is fine. Code. Input. Yeah, code is fine. Input signal. Output. Okay, fine. Yeah, this is fine.
Okay, sir. Thank you.
Anybody else who has written the code? Okay, we can stop for today.
Okay, sir. Sir, can we leave?
Yes, yes.
Okay, thank you, sir.
Thank you.